Servus Wien! Ich heiße Alex und ich komme aus Kanada. Mein Deutsch ist nicht so gut, so leider muss ich diesen Vortrag auf Englisch halten. So anyways, now that you know that I'm Canadian, what do you guys know about being Canadian? We're generally very friendly people, we're very welcoming, but one thing you probably don't know, which you're about to witness, is that we like to ask very personal questions. Okay? So this is a personal question for all of you here tonight. So what do you think was the cause of the last time you had major diarrhea? Okay? Very personal question. And for those who don't think that they understand what diarrhea is, Durchfall. I looked that up. And so anyways, I know what most of you are thinking. Maybe it's the schnitzel I had last night. Or that Leberkäse, but it tasted really awful. So, but very few people would actually think it's actually because of water. And in fact, for a very long time, since the 1900s, we've been chlorinating our water and killing a lot of the bugs that actually harm us. But now, we additionally have new technologies that are able to even remove more of the more crazier pathogens, like creepy names like Cryptosporidium. Okay? So these are actually much more harmful and much more difficult to remove from our water. So how do we actually deal with this water? We have pretty good water overall. So we have these technologies. We want to actually assess how well they actually perform. And we want to make sure that it's microbiologically safe. Sounds easy, right? We just test the water. Well, it's not as easy as you think. Lights, please. All right, so at a water treatment plant, maybe accidentally the filters got shut off and some chemicals got in. Ooh, yeah, that's right. But sometimes microorganisms that are particles can also get into our water. Okay? So we know in our source, let me see if this works. Ah, yes. It's contaminated water. Oh my God. So what do? We can test it. So we're going to take a small subsample of the entire water volume that's available to us, and we produce a lot of water in the drinking water treatment plant per day, right? We're going to take another sample and take another sample. But what are the chances that I can actually take a sample that contains the one pathogen that might actually hurt us? That's one of the major challenges that we have in drinking water treatment, trying to find those one tiny little organism that can actually hurt us. So that's part one. Now, part two is, okay, so this is where statistics, science, engineering, microbiology all come into play, okay? So we can actually look for places where the water comes from with a lot more microorganisms. If we can find a lot more microorganisms, we're more certain that they're actually there. We're not looking for a needle in the haystack, right? So we then determine how well our treatment processes actually work. And say, I'm an engineer, I can pull this knob, control the pH, do a little funky thing, and we would be able to figure out how much it actually removes. And so we know what the concentration is in the source, we know how much it can actually remove, and then we go on and figure out, by subtraction, how much is actually left in our drinking water. And we can actually put a safety factor to that and make sure that we definitely don't have anything in our drinking water. So appreciate that when you have a glass of water tonight. Now, the second thing that's most challenging in some of the drinking water treatment is when we actually go outside of drinking water treatment plants. So let's look at the natural environment, natural filtration. So something that you guys use here is riverbank filtration. So some of your water actually goes through the Donau into Donau Insel and some of these areas where water is pulled into the subsurface using the soil as a natural filter for your water to clean it up. But the subsurface. It's so vast. It's so mysterious and variable. How do you exactly quantify what's going on in the subsurface? And this is the question I'd like to answer for the next 3-4 years of my PhD. Anyways, with that being said, I will show you the cool lighting experiment. And as you can see, the chemicals can be anywhere, but the microbiology is really difficult to capture, that 1 in a million. So, who's with me? Los geht's. Let's make some water. Kaltes, klares Wasser. Danke.